In this video, I'm going to work through identifying the cations and anions present in solution N. We're going to need some chemicals for this test, and we're going to need the flowchart of identifying cations and the flowchart for identifying anions. We might also need to know some of the complex formula which, as part of this standard, we have to memorize. Okay, so we're going to start off by writing in, we'll do the cation test first, so I'm going to write in the cation present in solution N and then we'll write this answer in once we've figured it out. So the first test that we always do with the identifying cations is to add 2 drops of dilute sodium hydroxide solution. So I'll take a test tube and add probably about a finger width of our test solution. So there's our solution N, and you can see that I've got about that much in. And we're going to add 2 drops of sodium hydroxide solution to that. Now, I don't know how visible that is, but I think you can see that there is a white precipitate formed in there. And so I'm going to put that in the test tube rack to one side, and I'm going to write in the description of tests carried out. So add 2 drops of NaOH, sodium hydroxide solution, to a sample of solution N. Observations. So again, I'm using the flowchart. So we've added 2 drops, a white precipitate was formed, and so it could be any of these ions. So under observations, I'm going to write down white precipitate forms, so could be, and then taking them off the table of ions, it could be Pb 2+, it could be aluminium 3+, it could be zinc 2+, it could be barium 2+, or Mg 2+. Okay. Now, I'm not going to fill in the remaining 2 columns at this stage. We're only going to worry about those once we've identified which ion, which cation, is present in solution N. So our next step is to add excess sodium hydroxide. And so I'm going to take my sample again, and you can see there the white precipitate, and we'll add excess sodium hydroxide. Okay. And when we do that, we can see that the precipitate has disappeared, so it's dissolved. There's a tiny little bit left at the top, but if I give that a bit of a shake, then I think, yeah, we'll see that disappear completely. So hopefully you can see that. All right, so our test there was, as identified in the flowchart, to add excess sodium hydroxide and the precipitate dissolved. So we could be dealing with lead, aluminium, or zinc. So I'll write that in on the table here. When we added the excess sodium hydroxide, the precipitate dissolves, so could be lead, aluminium, or zinc. All right. So for the next test, we need a new sample, and we're going to add a few drops of potassium iodide solution. So we take a new test tube and add some more solution N. There we go, that's my amount of solution N. And we're adding potassium iodide. It says a few drops of potassium iodide. Now if a yellow precipitate forms, then we've got lead. And if there's no precipitate, we've narrowed it down to aluminium or zinc. Okay, so I've added a few drops of potassium iodide, and there's no precipitate that I can see. And so we are dealing with aluminium or zinc. I'll write that in here. So the step was to a new sample, a few drops of potassium iodide solution were added. And the observation there was that no precipitate formed, so could be aluminium or zinc. Okay, and in our final test here then, final part of the test in terms of identifying whether it's zinc or aluminium for the cation, we're going to add 2 drops, then excess ammonia solution. So we add 2 drops of ammonia solution and then excess ammonia solution. And that's to a new sample. So once again, new test tube, solution N, and the ammonia solution here is ammonium hydroxide, and it's 2 drops then excess. Now before I do it, if we get a white precipitate which redissolves, then it's zinc. If we get a white precipitate which remains, then it's aluminium. So here's a couple of drops first. Okay, and we have got a white precipitate, so that doesn't help us yet. We need to add more ammonia solution, so we're adding excess, and I would, be quite generous with my excess amount here. And so we can see here I've added about twice as much as I had previously. Now it's quite important probably to make sure that that solution is mixed, which is sometimes hard in these narrow test tubes. So I'm going to just try and give it a good shake there, and I can see that I've got a lot of the precipitate down at the bottom of the tube. I'm going to add some more ammonia solution. Okay, now at this stage I've got a little bit of the precipitate still in the bottom, but for the most part it seems to have dissolved. Now I'm just going to try and mix that as well as I can to give you an idea. Okay, and you can see, I think that the precipitate has dissolved, and so we must be dealing then with zinc. So let's write in this last step. So, to a new sample, 2 drops of ammonia solution were added, then excess NH3 solution was added. Okay, and the white precipitate was redissolved, so it must be zinc. So in our observations, a white precipitate formed and redissolved. So the cation must be zinc. All right, and at this stage I can write zinc 2+ up the top there, as it's been positively identified, and we now come into the equations. So here, wherever a precipitate forms, I'm going to need an equation, and wherever a precipitate dissolves, I'm going to need a complex ion equation. So up here, the white precipitate formed. We know that we're dealing with the zinc cation, so we start off over here with zinc 2+, and it's in solution, so it's aqueous, plus OH minus, and I like to leave a little gap in front of my ions or ionic groups, just in case I need to balance later. So I'm not gonna be squashing in a number between the plus and the ionic group if I need to put one in. The hydroxide is in solution, it's aqueous, and then we have an arrow, and because the zinc has a charge of 2+ and the hydroxide has a charge of a single negative, then we're going to need 2 hydroxides to balance the charge of the zinc. So our formula will be Zn brackets OH close brackets 2. There's no charge written here because the charge is balanced, and because it is a precipitate, the state is solid. So I write a little S in brackets. Because there's 2 hydroxides on this side, I need 2 hydroxides on this side, and so we put a big 2 in front of the hydroxide group there. Okay, and then that equation is finished. The name of the precipitate formed, now you can write this in words or formula. I'm going to stick to the formula because I've just written it. And that's my formula. Okay, so down here we've got a precipitate dissolved, and this was with excess sodium hydroxide. So we're looking at zinc again. And we're adding that to the negative ion here is going to be hydroxide again. And then the formula for the complex ion, which I have memorized, and you'll need to as well, starts with square brackets, Zn, and then brackets OH, close brackets, and then 4. Close the square brackets and write the charge to negative, and that is aqueous. Now, I would suggest that that's similar to like an 8 or 9 letter word, perhaps, and memorizing how to spell that word. I would approach this the same way. So write it out repeatedly, cover it over, write it out again, see if you've remembered it, and repeat that task a few times in a given day, and then maybe over successive days to make sure you have memorized the formula of the complex ions we need. So the formula of the complex is ZnOH All right, down here no precipitate was formed, so we don't need an equation. And at the bottom a white precipitate formed and redissolved, so we need another complex formula here. So again, we're starting with the zinc, that's our cation, And we're adding that, this time, we're adding that to ammonia. This is where the excess part came in. So NH3, and then arrow, and square brackets. Oh, I forgot my aqueous there. Zn, open brackets, NH3, close brackets, 4, square brackets, 2 plus, aqueous. We've got 4 ammonias there, and so we need 4 over here, and then we write in the complex formula again. So Zn brackets NH3, close brackets 4, square brackets 2 plus, aqueous. Okay. All right, and that is us for the cations for solution N. So next up, we'll do the anions for solution N.